learners, welcome to session 14, writing the equation of an ellipse in standard form. In this session, we will also try to determine the foci of the ellipse, the center, the vertices and the covertices, and we will extend up to drawing the graph of an ellipse. Before we begin, do not forget to subscribe and click the notification bell so that you get notified whenever I post new video lessons online. Let's begin! Let us try to work on this problem. Given the equation of an ellipse, 9x squared plus 16y squared plus 72x minus 96y plus 144 equal to 0, rewrite the equation in standard form, describe its major and minor axes, determine its center, foci, vertices, and covertices, and draw its graph. Okay, how are we going to work on this particular problem? Let me rewrite the equation here. We have 9x squared plus 16y squared plus 72x minus 96y plus 144 equal to 0. So we will start with rewriting the equation in standard form first. So how do we rewrite this one? The first thing that we're going to do is you transpose the sole constant. So in this case here, our sole constant, meaning there's no variable beside it, is this 144. So we transpose this to the right side of that equation. And so we have now 9x squared plus 16y squared plus 72x minus 96y equal to negative 144. The next thing that we're going to do is we write beside each other the terms with the x, okay, with the x's. So we will write 9x squared and this 72x beside each other. And then we also write beside each other the 16y squared and negative 96y, these terms, because they have the same variables, y. Okay? And then the next thing that we're going to do is we try to factor out whatever is common between these two terms with the same variable and these two here with the same variable. Alright, so 9x squared plus 72x, what's common among these two is 9. Okay, so we factor it out and what remains inside is x squared plus 8x. Okay, and then for the second group we have what's common is 16 actually, and so what remains is y squared, and this 96 becomes 6 because 96 divided by 16 is 6 minus 6y equal to negative 144. And then the next thing that we're going to do is we try to transform this into perfect square trinomial. Okay, so to do that, you already know how to do it. We just have to divide this second term here by 2. To determine the third term, we divide 8 by 2, that's 4, and then we square it, so we have 16. Plus 16 times this y squared minus 6y. 6 divided by 3 is, 6 divided by 2 rather is 3. 3 squared is 9, so we have y squared minus 6y plus 9 equal to negative 144. But since we are adding something here, we also have to maintain the equality, we have to also reflect that particular item addition in the left to the right side of our equation. But we cannot just directly add 16 and 9 because this 16 has to be multiplied by 9 first. Okay? So therefore, what are we going to add here is 16. Let's try to write it at this part. So 16 times 9, because this group means that we have to multiply 9 to each of these 3. Alright, so 16 times 9 is 144. 54, and that's 144. So we have to add at the other side 144. Because the 16 here has to be multiplied first by 9 before we can add it to the right side. Because it means at the side here that it's actually 144. Only in the form of 9 times 16. Okay, let's proceed to the next group of terms. So we have 16 16 times 9 as well. For 16, this one, and this. Okay? So, plus 144. Alright. So, now, let us transform this into a square of a binomial. So, we have x plus 4 times 9. And this other side here, we have y minus 3 times 16. While on the right, we can remove that. We have 144. Okay, so let me remove this. I finally was able to figure out how to delete just a portion of my writing. So now, the next thing that we're going to do, we are almost there. So, we have to come up with an equation where the right side is just equivalent to 1. So, to be able to come up with that, we just need to divide this by 144 so that we can have 1 at the right side. And because we are dividing 144 the right side of the equation, then we also have to divide the left side by 144. And so, what we will have is 9 divided by 144 will give us 16. Okay, so we have x plus 4 over 16 plus 16 over 144. That will give us a 9 at the denominator. Okay, 9. And then we have y minus 3. This is squared actually. Squared, and this is also squared because these are perfect square trinomials which we have rewritten into a square of a binomial. And this is equal to 144 over 144. That's equal to 1. Alright? And so there we have it. This is now the standard form of the equation of the ellipse. Given this 9x squared plus 16y squared plus 72x minus 96x plus 144 equal to 0. So when we transform this into standard form, this is how it looks like. Okay? X plus 4 quantity squared all over 16 plus y minus 3 quantity squared over 9 equal to 1. So let me write here, let me copy here the equation that we were able to come up with from the given equation here. So we have x plus 4 quantity squared over 16 plus y minus 3 quantity squared over 9 equal to 1. Okay, so from here we can say that a squared, the bigger denominator is 16. 16 is bigger than 9 and 16 is over the numerator with an x. Therefore, the 16 here is our a squared. A squared is equal to 16 and our b squared is equal to 9. Solving for a, because these are important when we try to write the details, when we describe our major and minor axis and its center, the foci, the vertices and covertices. A is equal to 4 and b is equal to 3. And solving further for c, c is equal to the square root of a squared minus b squared. Therefore, we have a c equivalent to 16 minus 9, and that's equal to the square root of 7. Okay, and so moving forward, when we describe our major axis, we can say that since 16 is below the term with an x in the numerator, therefore the major axis is horizontal. And that would tell us that the minor axis here is vertical. Okay, now let's proceed to finding the center of our ellipse. The center would be at, given this and this one, the center would be at negative 4, 3. Okay, now let's proceed to finding the foci of our ellipse. Okay, so since the major axis is horizontal, so its y-axis, y-coordinate rather, would be the same with the center. So it's going to be 3, and its x-coordinate would be the same with the center, but we have to add and subtract there our c value, which is the square root of 7. So therefore, it's going to be negative 4 plus minus square root of 7. And the that would tell us that actually our foci is located at -4 minus square root of 7, 3, and at -4 plus square root of 7 and 3. Okay, let's proceed now to our vertices. The vertices would also be collinear with the center and the foci. Therefore, the y-coordinate of the vertices would be 3, and the x-coordinate is -4 plus minus the a value here, which is 4. Which tells us further that the vertices would be located at -4 minus 4 is -8, 3, and at -4 plus 4, that's 0, 3. Let's proceed with our covertices. Our covertices would be vertical here, and so because it's vertical, it's the x-coordinate of the covertices that would be similar with the x-coordinate of the center. So it's going to be -4, and the y-coordinate would still be 3 plus minus the b value, which is 3, which tells us that the covertices is at -4, 6, and at -4, 0. Now it's time to plot the graph of our ellipse, to draw the graph of our ellipse. Let's begin with the center. The center is at -4, 3, so let this be -4 here, and this one is 3. So the center would be here. The vertices is at -8. Let us say this is -8. Okay, -8, 3. And at 0, 3. Okay, so the foci is at -4. Let this be our -4 minus square root of 7. And so this one is -4 plus square root of 7. So this would be where our foci is located. Let's proceed with the covertices. The covertices would be at -4 and 6. So let this be 6 here. This is where our W sub 2 is located. And -4, 0, this is where our W sub 1 is located. So this is F sub 1, this is F sub 2, this is our center, HK, this is our W sub 1 and W sub 2, and our vertex 1 and vertex 2. So this is our minor axis, and this one here is our major axis. And let's try to connect the points with a smooth curve to finally illustrate our ellipse. So this is how our ellipse looks like. Alright? And so there we have it. This is x plus 4 quantity squared all over 16 plus y minus 3 quantity squared over 9 equal to 1. That's it, math learners. I hope you have learned something today as we explored more on the equation of an ellipse in standard form, determination of its foci, its center, its vertices and covertices, and illustrating its graph. Stay safe always. Bye!